Okay, so welcome back to chapter 3, where we're going to bring all of our game now to life. So if you haven't been here before, please hit that subscribe button and follow my channel. Don't forget to hit the bell to stay notified of when I publish new videos, because I'm back on it after a little bit of a break over a year or so. Okay, so picking up literally at the end of chapter 2, we are now bringing the asteroid game to life with our little spaceship. We are going to be creating asteroids. We're going to be firing the laser at the asteroids. We're going to be moving the ship left to right. We're going to talk about a game loop and how that updates the game so that the scores become dynamic on screen. So as we fire or lose a life, it's in real-time score keeping for us. We're actually going to have to handle collision handling. That's when we hit an asteroid and or our laser hits the asteroid, what happens with it, or even if asteroids hit themselves, I'm guessing. And then at the end we will look through all of the new concepts that we have learned in this chapter. So moving back from where we were, our game at the moment is built, but nothing moves, nothing is interactive. And our code, we left it on line 9091, where we had just updated the text to the screen. Okay, so moving straight on to our chapter 3, we're going to start by creating asteroids. Now obviously there are going to be many asteroids, as you can see on that photo, which means instead of having to repeat the same lines of code over and over, we are going to create the code once, and we're going to call the function that that code lives in multiple times. Again, it's a local function, so this function can only work within this file, and it's going to be called create asteroid. Okay, so moving on down here, let's actually start by now grabbing one of the asteroid images off of our image sheet and populating this. So we are going to create a local variable called new asteroid. So this is a reference to each of the asteroids. Notice that the local and the asteroid is inside this function, which means this actually cannot live outside. So if I try to call new asteroid from any other part of code outside of lines 93 through 97, it's not going to recognize it or create an error. So this becomes important the more complex our code gets, as to be able to segment and organize our code and what can call and talk to what. Okay, anyway, moving back on here, this is a display library object which we're going to use as a new image rectangle. We're going to place it in the main group. Remember, there are 3 layers to our game. We've got the background, the main, or I call it the foreground, and then we've got the user interface. So obviously our asteroids need to live in that middle layer, so they're on the background but they're underneath our live score. And then we're going to grab it off of the object sheet, and we're going to grab the first frame, and we are going to tell it its width and its height in image size. Okay, so just to recap, in our previous chapter we had an image sheet, asteroid 1, there its width, there its height, but we could also play with those. We're keeping it the same, but we could have actually changed it if we wanted to. Okay, so next part. Now, oh, I skipped a line. There we go. So now, because we are going to create many asteroids, we are going to have to create a table to store those asteroids in, because otherwise if we have to individually reference one asteroid at a time, it's going to be a bit of a nightmare and hard work for us. And as they're all the same type of object, doing the same type of thing, behaving the same type of way, it's actually easier for us to group them all together into a table called asteroids. So here is a command line that basically says create a new table object called asteroid table and assign to it this new asteroid that we have just created. And obviously back up further in our code, if I do a control find and then search back up, we can see here that we've got this empty table ready and waiting for us to populate it with content. Okay, all is good. Okay, so then we skip down here. Now obviously an asteroid is a physical item, which means it can bang into other items. So we therefore need to give it a body in the real world of physics. So we've already added this library in, and we're going to give it a dynamic entity. So unlike the platform in our balloon tap game, which was like the Earth and everything else on the Earth moves, such as people and humans and balloons, our asteroid is out in the cosmos, and it can go up, it can go left, it can go right, so it needs to have a dynamic status. Now again, we need to be able to identify with the app, give the code the ability to understand what is the actual asteroid. And the easiest way to do that is to use a radius, which is a circle. Think of it as like saying, putting a coin on top of a piece of paper and saying anything underneath that coin is the area that we can hit. So we are saying there's a round disc of 40 units wide and tall and whatnot, because it's circular, and that is going to encompass our asteroid. So it gives us kind of like a zone that we can tap in. Then we have the ability to bounce it into other asteroids and off other things. And again, back to our physics with our balloon yesterday or in our previous chapter, if it was set to a 1, that would be like 100%, which means it would bounce and it bounced back exactly the same distance. If it was 0, it would have no bounce at all. And so 0.8 is slightly more than half a bounce, but not quite as much as a full bounce. So now we've got an asteroid that knows what to do when it bumps into other objects. Moving down here, we're going to be really nice and give our little asteroid a name. So our asteroid is going to be called Asteroid. So there's our object. We're using the parameter called my name. It's reference to it, and then we're actually putting that text in the quotes into that parameter field of our object, which is all good. Okay, so moving down further, we now need to create a direction or a means of creating a direction from where our asteroid comes from. So if we just quickly come back up here to our game, obviously our ship's at the bottom part of the screen, so let's say the bottom half of the screen, and you can see here there's an asteroid coming in from the left, and there's one coming in from the right, and we could also have them come in from the top. So if you think when you start counting and looking at objects like this as a display, the left is always side 1, then we go top in a clockwise direction, and then we've got the right hand side, and then we'd finish with the bottom. So we've got sides 1, 2, 3 and 4, but we don't want asteroids to float in from behind us in this particular game. So we are only going to be looking at sides 1, which is the left, 2, which is the top, and 3, which is the right hand side. So going back to our code, where's our code gone? That's why we've only got a number 3 here. So basically what we're doing is we're creating a variable called wherefrom, which is going to be a placeholder for a number. And that number is going to be randomly generated between the numbers of 1, 2 and 3. And the computer is going to assign a random number, one of those numbers, in here, and that is basically going to represent the side. It's going to be side 1, side 2 or side 3. I've lost where I am. Here we go. Okay, so now we need to actually do something so the computer or the program itself can actually identify where from the asteroid is coming. So we're going to use a decision statement called an if statement. Now, just like your mum might say to you, if it's raining, put a jacket on, and if it's windy, put a jumper on, and if it's sunny, put some sunblock on. There is a decision process there. If something is occurring, do X. If not, do something else, and you can go on and go on and go on because there's hundreds of different types of weather. This is exactly the same in programming. We give it an if statement to make a decision. And so we're going to start with our first control item that we need to test for. So our wherefrom is going to be holding one of these values. It's going to be holding the value 1, or it could be holding the value 2 or the value 3. So we need to compare whatever it's got inside there and see if it's compared to that value. So we're saying if that value is the same as that value, comparing it to one another, then we're going to go and do whatever lies between these two lines of code. Okay, now when you've got two equal signs together, it's a comparison. When you've got one equal sign on its own, it's an assignment value. So basically here we're assigning anything on the right hand side into the left hand side. 3 plus 3 equals answer. That's how you was taught things in maths at school, but in our world, answer equals 3 plus 3 is essentially what's going on there. And when we're comparing, it's just a way of saying, just check out whatever's in this variable if it's the same as that variable or that value. Okay, now that we've got the bare structure set up, we actually need to check if it's from the left hand side. Okay, so if I quickly, oh, I didn't mean to hit that there. Okay, so if our asteroid, side 1, is from the left, We know this because we are going to tell it where the X and Y values of the asteroid can possibly be created from. So over on this diagram just above me, remember that the 0, 0 is the very top leftmost corner of the screen. Now anything to the left of that is off screen, above it is off screen, and to the right and to the bottom. So we know that if that's 0 and we go from that x-axis from the left to the right of the screen, the number's going to be positive and going up, and anything going to the left of it is going to be a negative number going down, and that's why we've got the value there -60. So it basically means that our asteroid has to be created on this x-axis somewhere to the left of our screen. Then we have to deal with the y-axis. Now the y here will be from 0 at the top, any length of this height of the screen. Now, as I said to you a moment ago, we don't want the asteroids to appear alongside us or behind us. So we're going to have a cutoff as 500 units going down. Now remember, in the world of Lua, the positive and negative is flipped compared to when you're maths and doing a map reading out in the countryside. So any number that is going south is going to be a positive number, at which point from 0 we're going to go 1, 2, 3, 4, 5 and all the way down to number 500. So we're therefore then telling it to grab any number between 0 and 500. So it could be anywhere in that red bar. Basically the asteroid will be created on the left hand side of the screen. Now that we've done that, we also need to tell the asteroid how quickly to move across the screen, okay? At which point we've got a velocity. So when you put your foot down in the car and the car speeds up, that's your velocity, that's how fast you're traveling. We need to tell the asteroid how fast it can travel. So the velocity always has to have coordinates on the X and Y axis as well. So again, basically you think you've got your object here, and it's basically we've got to tell it how fast we're going to move side to side and how fast we're going to move up and down. Okay, so therefore we need to have an X axis, which is your left and right, and a Y axis speed, which is your north to south. Okay, and that's why each of these has a a minimum and a maximum speed, because we don't want every single asteroid on screen to travel across the screen at the same time. We want some of them to be zippy and go fast, and we want some of them to, you know, toodle along slowly, and so all the asteroids will move at different speeds. So obviously we've got the X axis, so how quick do we want it to move from left to right? Well, our minimum speed will be 40 and our maximum speed will be 120 on the X axis, and then on the Y axis our minimum speed will be 20 and our maximum speed will be 60. Okay, now moving on down, that's what all of this just here explains, but obviously that's only one side, that's the left only. We also have to deal with the top of the screen and asteroids coming in from the right hand side of the screen. So because we are continuing that decision process, we now have to involve all the multiple else if statements, of which we've got 2 on screen here, but our if statement could actually end up with hundreds of different else if statements if we wanted. It would be a bit messy, but we don't have to just have 2, we could have 10 else if statements or whatever. In this particular case, as we are only dealing with 3 sides, the first side, second side and third side, this is as much as this statement needs to be. So I'm just going to copy this code. It's more or less the exact same principle. There's a couple of tweaks because obviously different directions. So let's quickly just work through that. Obviously now we're comparing the value in here that's been randomly generated to see if it holds the value 2. If it is true, and that is correct, it does hold the value 2. Then and only then do we enter this part of the statement and execute this code, at which point it's going to basically place it anywhere. So if we go back up here, we can place it anywhere on the x-axis as long as it's north of the value 0. Okay, so let's come back down here, and we're going to take it 60 above the line 0. Again, if you look at this asteroid up here, the asteroids, we don't want them appearing suddenly from nowhere half on the screen. So by having them completely appear off screen, as they float onto the screen, they float onto the screen as an entire item that doesn't suddenly appear. Remember, although the screen works, when we're placing things on the screen, the coordinates start from 0, 0 in the top left corner, but when we refer to an actual image or an object, its reference or anchor point is its very central location, as we'll see, as we saw in the previous chapter when we placed the ship and it was right up in the corner, but only a little bit of the bottom right corner could be seen. Okay, so now we've got that on here, we've got the velocity, we've got our and the right hand side is exactly the same as left, but obviously the parameters are positive because we're on the right hand side of the screen. What we need to do now is we need to actually apply a spin on the asteroid, because all our asteroids aren't going to just move across the screen in one position, they're going to tumble and they're going to spin. So we're going to use this torque and a number to sort of give the asteroids the ability, or the images, the ability to spin around in circles. Okay, so first of all, we're going to grab that object, and that's what we're going to apply this this command to. Again, we're going to random generate a number, but don't forget, we are either going to be able to spin it left or we're going to be able to spin it right. So if it's a minus number, we're spinning it to the left, spinning it to the right, and the speed it rotates is depicted by the values like minus 1, 2, 3, 4, 5, 6 or positive 1, 2, 3, 4, 5, 6. So again, we randomly don't know which way the asteroid is going to go and how quick it's going to spin. They might just turn very slowly, or it might be quite a rapid thing. So now we've got the effects of the actual asteroids doing their thing. What we're going to do now is work with the firing mechanisms, because obviously we want to be able to, let's move this up, we want to be able to fire beams of light at our asteroids to blast them off the screen. Okay, so we're going to start by grabbing this. So that's the end of that function. So let's give ourselves some space, and down here we're going to create another function. This one's going to be fire the laser. So if you imagine the captain shout fire, every time he shouts fire, the operator's going to hit that button, and that's going to be us hitting the button or our finger on our spaceship. Okay, so first of all, we're going to have to create the actual laser beam itself. So we're going to put a display object on the screen, which is a new image rectangle. It's going to live in the same layer of our game as our asteroids and our ship. We're going to grab object number 5 or frame 5 off of our image sheet, and that's its width and that's the image height. We're going to give it a dynamic body yet again, and this time it's going to have a sensor which we're going to turn on as true. So it's going to have a sensor because obviously it's going to need to know as a little object on its own right whether it's actually bumping into things or not. Okay, we are going to call it a bullet. That's going to be used later on, so we're going to set that as true, and we're going to give it a name so the object itself flying across the screen knows what type of object it is. Okay, so there's the firing mechanisms. Now we need to place the laser on the screen. Now obviously it depends where the ship is going to be located, so we are going to create ourselves a little space, and there we're going to create it in relation to where the ship is going to be. So don't forget, this object has its own X and Y coordinates, and all we're going to do is we're going to borrow them from the ship. So wherever the ship is on screen, grab its X location and give it to the laser, grab the ship's Y location and give it to the laser's Y location. So that's nice and simple. Then, as you can see in this image on the right hand side, what we want to do is we want to send it to the back. Now the reason we want to send it to the back is because if you remember in our linear process of loading and creating images, the first things that get loaded go at the bottom, and then we layer on top and we layer on top, and we just stack them up as if we were stacking a pile of plates. So as this is one of the newer items of code that we've just created, it's going to live at the top of the stack. But as you can see on this little image, you know, having the ship fly around the screen with a laser beam on top of it looks a bit daft. So we don't want that. We need to swap the arrangement around. So by using 2 back, what we're telling the laser is create the laser, it's sticking it on top, and then very almost instantaneously we're going to slide it underneath the ship. Now because the laser actual image is smaller in size, it's therefore now hidden behind the ship and we can't see it. The computer game knows it exists, but it's not available to the human eye to be able to see on screen at this moment in time. Okay, then we need to give the ability or tell the laser how it's going to fire. Okay, so when a fire beam is in action, it needs to move from one location to another. So that transitioning period is how we're going to move it. Okay, so we're basically saying here, we're going to transition the object laser 40 points north, so that's why it's got the minus 40. So wherever the laser is on screen, that's 0, and then we're going to count 1, 2, 3, 4, 4 up to 40 going negative number going north, and we're going to do it in half a second. Now in the programming world, everything is done in milliseconds, milli meaning 1000. So instead of saying 1 second, we could say a millisecond instead. It's the same terminology, and obviously half of 1000 is 500. That's how I could tell that this is half a second, that it's got to move from the ship to its final destination, which is 40 units north of the ship, in half a second. So that's going to give us the appearance of the laser beam being fired. Then we are going to finish it. So I'm just going to copy the whole thing again just to quickly show you. So at the moment that statement is finished, but I'm just going to over paste it. All it's done now is, in fact, actually, because my screen is wide enough, they've probably just wrapped it to show you, but I am just going to put all of this into a different line. So I wouldn't write the code quite like they've done on screen. I would write it, because this is a function, and then we are going to, there we go. Okay, so what we've got here is the new statement. So we've already dealt with these two. These are the first two parameters, but we can also have this third parameter, which is an entire statement, an entire function on its own. So what we're doing is we're declaring a new variable called onComplete inside this laser command as one of its parameters. We're calling it a function, so it knows it's a function, and it knows that when the laser has finished moving, we're going to remove it. So we have to basically, we are telling it where to, how far to travel, how fast to travel, and what to do when it's finished traveling is the third parameter here. But obviously, instead of having a quick statement like on the previous two parameters, we've actually given it another function. That function happens to be called onComplete. Okay, so that's what we've got going on there. And then we have finished what we're doing for the moment, finished with our laser almost. We now need to give it a listener. So just like we did have to listen to when the balloon was being tapped outside our function, we need to know to listen for our ship being fired. So when our ship is listening constantly for a tap to happen on it, it needs to know what to do, and it's going to fire off, or it's going to call the function fire laser, and then the fire laser and all of this code is going to execute. So now our ship is ready to listen for that command. So let's hit save and see what happens. There we go, and there is our laser beam. It's going in a dead straight line in front of us because we've not given the laser beam an X coordinate. We've only told it can go on the Y axis and it can only go 40 units north, and then it's going to disappear. So all is good so far. Right, now we're going to move the ship to left to right because it's a bit of a boring game with the ship just being stationary there. So we need to be able to drag it left and right across the screen. Okay, so this is what the next function is going to do. So first of all, let's create that function structure. Okay, so the only thing that's different with this function is that this, as we create this function, it's going to be listening for events. Okay, where are we? Okay, so what we're going to do now is we are going to get our variable local ship. Okay, so we're going to give it a target so the ship knows that it's going to be the result of an event taking place. Now, instead of tap, which is a microsecond when you hold the button down and release it instantly, we are going to use a touch event which has 4 different statuses. It's going to begin touching, you're going to move and drag, then you're going to release the button, or your finger off the screen, which is going to be ending, and there can also be a cancelled. Ending and cancel are very, very similar. One is human orientated, as in the action created by the human finishing touching, and cancelled can be one that's called by the system itself. So often what you'll find is ended and cancelled will be bundled together when people write code, because it's not always needed to write a full statement. So let's go on, get down and do this. So we've got our if statement again here. Okay. Okay, so now we're listening for an event, and that event can be anything. If it happens to be begun and the phase has begun, where has we got phase? Oh, I haven't put that in there. Give me 1 second, that would make more sense. There we go, my bad. So we've got an event now called phase. So if phase is equal, whatever's inside that, so we're going to create this function, it's going to hold an event and it's going to hold one of those 4 words. Well, it's going to do a lot more than that, but we're going to grab the phase of the event object and we're sticking it in that word so it's quick and easy for us to access it. And now we're going to compare what's inside it. If it happens to be that we've just begun dragging the ship, then we are going to display the current stage as set focus to ship. So think of this as a stage where there's lots of performers acting on the stage, but then suddenly the spotlight goes on one person. All eyeballs in the crowd go on that one person. Although we can see everything else that's going on the stage, our focus is set to the person with the spotlight. This is essentially what we're doing, and by doing this we're telling the audience who are looking at the theatre performance, put your eyeballs on this person. In the term of code, we're saying to the mobile app, put all your attention into what's going to happen with the ship in the next few seconds. Okay, now we've done that, what we're going to do is we are going to grab the starting location of the ship. Okay, so let me just put that in the correct place. Okay, so wherever the mouse is on the screen that we have just clicked, that's going to create an event, and that event has an X and Y location. So we're going to grab the X location. We're going to take away the X location of the ship. So basically what we're doing is we're comparing where our mouse is in relation to where the ship is. And then we're going to store it as a slightly offset. So basically the ship image itself and the radius is based in the very center here where I'm wiggling my mouth, but obviously we've got an area around it. So the image center, how we refer to an object, the object is always going to be placed on the very center of the object or the image. So the display works top left corner, images and objects work in the very center of the image and objects. But obviously we might not necessarily be so accurate with our finger or our mouse to be able to click on that precise location. So what we need to do is, we know the size of the ship because we gave it a radius. So any size anywhere in there, what we need to do is basically compare, is the click happening inside the zone or outside the zone? And this is where the offset comes in. So by having the event here, which is the click itself, cross compare to where the ship is located, that gives it our touch offset on the x-axis. Because they don't want the ship to be able to go north and south, it can only stay going left and right. We haven't got a y-axis. So that's basically how we're going to control the ship and the touch and identify whether it's inside the zone or we're just clicking somewhere out in the cosmos on our app. Okay, so that's how we're going to identify whether to be able to drag or not. So now we've got the begin phase of our touching action taking place. What we need to do now is say what's happening in the moving stage. So we're going to copy that code and pop that down here. Okay, so now this location, wherever it is that we've grabbed our ship and we're moving it across the screen, that's going to update at rapid speed. Okay, so the X location of the ship, the X location of our button, the X location of where all of these events are taking place are all going to rapidly change really fast. So we're going to have to keep updating everything so that the ship then gives us the appearance that it's moving across the screen. Okay, so this bit here just is all it's telling us is if you, however, wanted to create a game that was able to go north and south and move our ship in other directions other than just left and right, then obviously you'd need to have this code where it's got a y-axis as well built into the code, and that's how you would alter your game to include it moving up and down as well. Okay, so now we've done that, you can see here we've got ended and cancelled. These are the last two phases. So this is human controlled, when we lift our finger off the mouse button or off the display, and cancelled would be if we wanted to ever code something to do with the system taking an action as well as a result. As we don't in this game, we're actually combining the two into one statement, which is why we've got that or statement there. So basically, if the touching action of dragging has ended or cancelled, then and only then do we remove the focus from the stage. And obviously that's like the spotlight on the actor going off to do something else. So there we go. Okay, so that's where we've now set the focus to nil. Okay, and then finally, we're gonna have to say, as in like a kind of, okay, that's it, job done, closure on that action. We're going to put we're going to return true to the computer. Finally, of course, we need our touch listener this time. Okay, so now we've got the code doing what it wants. Right at the end of it, we are going to add a listening event to the ship, so that anytime we touch the ship to drag it, we're going to go drag the ship, and all of this code here will then execute. So let's hit save and see if that actually should work now. So there's our ship, and now we can drag it. Now I'm trying to pull it. As you can see, the mouse is going north, but I can't move the ship north. That's because there are no controls whatsoever to say go north. One thing to bear in mind is I can drag it right over. Now I haven't released the mouse button, but you can see that the ship technically is way off screen, right underneath the location of my cursor, and it comes back on, and likewise on the right hand side as well. Okay, so that might be something that we might need to catch if they don't actually write that code into the game. We might need to put like boundaries as to where the ship can go on the left and the right of the screen. Okay, so now we've got to loop the game. First of all, we've got to update the scores regularly, and obviously asteroids are going to be coming and going really quickly. They're going to be creating, they're going to be banging into things, the laser's going to be frying, so there's a lot of things that need to be updated in milliseconds or less than milliseconds through the game. So we're going to create some sort of game loop, and with that we are going to call the function create asteroid. So remember, everything in Lua is linear, so at the moment we've created all of these things and we're going all the way down the game. Okay, and the way that we can go back up to previous code that's been pulled into memory is by calling a function. So we've got down to here, so this is all loading into memory, and now we're actually going create an asteroid. So we've got to go all the way up here in the code, and basically the game is going to start like reading at 993, and it's going to execute all of this, gets to line 120 and go job done, and it's going to come back down and then read line 166. So that's how calling a function essentially would work. Right, so now we've called our asteroid. What we're going to do is we're going to remove asteroids which have drifted off of the screen. Now we're going to do that using a for loop. Copy. So what is a for loop? Well, we've got to create a continuous situation that the game knows to keep it updating until something happens to tell it to stop, because we're not going to tell the game to keep playing. We are the player, we're involved in the game, we're not controlling the game. So what we need to do is create a scenario where the game constantly plays until something happens that the game stops, like we run out of lives, then it would stop the game. So we're going to use a for loop. Now something that's quite handy for you guys to learn is that there are lots of resources out there, one of which is the Lua organization themselves. And if you was to go to the Lua website right now, for example, you could look up the for statement, okay? And at first glance, this is going to be like, what does that mean? It's basically giving you a syntax here as an example of how a for loop would work, and then it goes on to explain it. Essentially, it's going to, for the values, while these exist, keep doing something that you're going to code there, and then eventually you will go back up here and go through it, do this again and again, and at some point one of these details are going to hit at like an expiry, or something's not going to be valid anymore, and then you're going to end, at which point that's how we can keep looping and looping and looping and looping. So we could keep playing while we've got 3 lives, we could keep playing while we've got 2 lives, we can keep playing while we've got 1 life, but at some point we're going to hit no lives in our game, and we're going to have to tell the game to stop, game over. Okay, so that's one example of how to use a for loop. So this is also a good resource for you guys to have access to. So in here, we are going to create an index. It's like a variable, which is going to be like a counter. We're going to just call it I, just for the simplicity of holding a counter. Now, a shorthand way of working out how many asteroids at any one time has been created and or before they've been destroyed is to count how many that are in the asteroid table that we've got going on. So that hashtag at the beginning of the asteroid table name basically says count how many asteroids are in the table and report back to us. Okay, then we're going to grab just one asteroid, one at a time. And we're going to do that until there is a value of -1 asteroids remaining. Okay, so all the time there is an asteroid with a positive number. So obviously if there's 0, then there are no asteroids in the table. But if that's just a 1, then there's only 1 asteroid in the table. We're going to keep looping through this. So all the time that this for loop exists with positive numbers in here, then we are going to do whatever it's going to tell us to do. So we are going to remove asteroids which have drifted off screen. That's our target. So there is our for loop, and this is the code that we need to put inside it. So again, let's just quickly go down here. Okay, so we've got our local variable saying this particular asteroid. So remember, we're going to grab one asteroid from the table at position 1. So this counter has got the value of 1, for example, and then it's going to say if 1 and its x position is less than 100 points, or its x position is greater than the width of the screen plus 100 points. So basically go back up here, where's our screen with the thing, where's it gone, there. Okay, so we're saying 100 points to the left is over here and 100 points is slightly over to the right. So if this asteroid's x location is greater than 100 to the left or 100 to the right, then it's clearly off screen. We're going to be able to destroy it. Okay, then obviously we've got the same sort of parameter going on here with the y. So if our asteroid's y location is greater than minus 100, so minus 101, 102, 103, etc., then clearly it's way off the top of the screen. And if it is greater than 100 at the bottom of the screen, then it's clearly gone off the bottom of the screen as well. So that's basically how we create the borders of our zone for where we want asteroids to exist or not within memory. And then we are going to remove this asteroid. So all we're going to do is in the same way we kind of put an image on the display, we're going to remove an image off the display. All we're going to do is say the display, remove that image. The image happens to be called this asteroid, and that's taking it away from the physical human eye looking at the screen, but don't forget it still exists in the data in the table, and we have to remove it there. Otherwise we could end up with a table that's got thousands of asteroids, but there's only 2 on screen. So we also have to remove the asteroid that lives at the location I, which at the moment is the counter of 1, and we're going to remove it from table 1. Okay, now obviously as this time is going on, the time is generating the asteroids. The asteroids are coming in from the left, right or center. They're coming in at all different shapes and sizes and speeds, and zooming off at all sort of speeds and this, that and the other. That table is updating rapidly all the time. Okay, and so that I value could go up to, say, there's 30, and we're looking at we're dealing with the code at the moment, the asteroid in position 30 in the table. We don't know. So this is why we use placeholders for the numbers and the counters of which asteroid or object we're referring to in the table. Right, so where are we now? So now we have got our asteroids. I've gone up the screen, haven't I? So moving the ship left to right, we've done all of this. Done. Asteroid cleanup, we've just done. Okay, so that's just kind of explained everything I've just done there. Again, one of those ways to bleed memory is to not remove the objects from data as much as it's easy to know if we've removed them from the screen, we see it or not, but it's easy to forget that we also have to remove it from the memory of the device. Now the loop timer. So what's happening here is how quickly does the game actually have to update the screen, okay? So we are going to come down here and talk through this. So in the same way outside the function, we've got our ship event listeners or our event listeners to our objects. We need to know what is going to trigger us calling the game to loop and loop and loop. And then obviously when that function's called, we enter this for loop scenario until we break out of it. So as the code is linear, let's just reduce this down to help you walk through it. Okay, so remember we're, we're creating our code, okay? We've got all of this code going on at the top. Let's just reduce some of this down so you can see. So reducing it down, we've got our code. It's going in to do whatever we've told it to do in there, and all of these same functions. At some point, we're going to hit this and we have to automatically call the game to start playing, okay? And that's how we do it. We actually say to the entire game, give the computer or the mobile app or the tablet time to read in the code, wait for half a second for it to kind of literally load the code into its memory, and then as soon as half a second has passed, we are going to call the game loop, which is where that function to loop exists, and we're going to keep doing that until that 0 there is our representation of basically saying never stop, okay? Because the stopping mechanism is going to be inside that loop. Okay, so, oh, well, here it goes. So we are, let's have a look. It's saying, finally, we include the operational, the iterations parameter is 0. So this is how many times we're going to keep calling it. So that statement is called, it looks like 0 times, but it's not. Okay. If you include this parameter, the timer will repeat that number of iterations, but don't be fooled by this 0 being, we are not telling the timer to run 0 times, which is what I was trying to explain. Instead, what we're actually trying to do is we're saying if it's 0 or a -1, this will cause the timer to repeat indefinitely unless we use it a pause or stop button. So obviously our stopping process is going to be when we run out of lives. So that's going to be our stopping mechanism. So by putting the value 0 in there, our game knows not to ever stop until something else calls stop to the game. So I'm just going to hit save right now. Okay, so now we've got that far. Let's have a look what's we got now. Now we're going to go into collision handling. So time to handle the collisions. Initially, we're going to detect some collisions, okay? We're going to work out when the laser collides with an asteroid. So that's the first type of collision. And the second is what happens if an asteroid collides with the ship. So there's two types of things we've got to handle here. Collisions are reported between pairs of objects. So we need to obviously have the ship and an asteroid and the laser and the asteroid. There's the two pairs, okay? Right, so we have to use an object listener, or we can use a runtime listener, which is just basically the entire game paying attention to what's going on. Different games require different methods, but there is a guide. A local collision handling is best utilized in a one-to-many collision. So there is, say, for example, one laser hitting many asteroids. For example, one player object might collide with multiple enemies and power-ups. Then there's a global collision. This is basically our way of understanding which type of collision handler we need to use in this game. That is in a many-to-many scenario, which is, for example, many hero characters which may collide all at the same time with many multiple enemies, okay? Whilst this game just has one player object, the ship, it might seem that it's best to choose a local collision. However, the game also needs to detect collisions between other objects, such as the lasers and the asteroids, etc. So we're going to have to use a global collision handler, because in any one moment, lots of collisions of all sorts could be happening, okay? So first of all, restoring the ship. Before we get into collision handling, we need a function that can be called to restore the ship following a collision, because obviously if an asteroid kills our ship, we need to be able to reuse the life and come back on screen. In our game, we'll mimic the classic arcades game where the ship fades into view. It's temporarily invisible, and after all, it wouldn't be fair to allow players to die consecutively times without being the chance to dodge some more asteroids. So here is how we're going to restore our ship if it's just been hitting an asteroid. So let's have a look at this code. Okay, so we are going to call a function called restore ship. Ship is body, active is false. So that's basically giving us a status of whether the ship is in a true status of play or a false status of temporarily out of action. Obviously our X and Y locations and the heights and the screen, that's fine, of the ship. So when we reposition the ship back on screen, it's got to reappear back at the very bottom center of the screen. And when we do that, we're going to fade it in very slowly. So that's taking it from completely invisible through to fully solid object as a visual thing that we can see over a course of a few seconds. So in this instance, The alpha, fully solid state, will be 1. We're doing this transition to the ship. So this isn't a movement transition, this is a fading transition. We're going to take 4 seconds by which to make this fade appear. Okay, and then when the actual fading in has finished, on complete of that, we're going to then rewrite the is body active to true. So now the ship's back in play, so it can now, so obviously it'll be unfair of us to allow the ship to be hit by asteroids when it's not even fully on screen and it's only half visible. So once the ship is fully visible once more on screen, we're going to turn its active to true and its died status back to false. Okay, so we're just flipping the controls on what's happening to the ship. Okay, so collision function. So what happens when there is a collision? Copy. So on collision, there's an event takes place. Again, we're listening to this global event. Sometime the game's got to figure out what's going on. First of all, it's going to have a begun phase, as we already worked out before. Then we need to find out what's going on. So we're going to grab object 1. So remember, there's got to be a pair. It's got to be the ship and an asteroid, or the laser and an asteroid as the pairing. So we've got to find out which is object 1 and which is object 2. So we don't know what order the event is going to report this to. So it could be that the ship is the first object and the asteroid the second object, but likewise it could be that the asteroid is being reported first and then the ship second. So we've just got to grab these 2 pairs, but at the moment we don't know which way around those 2 pairs are, which is why we've got their names. So now we've got objects 1 and 2, we are going to be able to, we've got to basically test to see who we're dealing with. So we are still inside the if statement. Okay, so we've got a nested if inside an if. Okay, so if object 1's name happens to be the laser and the object 2 name happens to be an asteroid, woohoo! Or if the first object is an asteroid or the second name is laser, then we're going to have to do something. Okay, so the then is we are going to remove the 2 objects from the display. Now, I don't like the way that they wrote this code. I would never do that. So this would be how I would write my code. So that's the opening if sentence line, and now we've got our if statement there. This is just my preference. You can follow the screen if you want, but as I've got a nice big wide screen here, and you will find that most people will put all of the parameters on the same line. In fact, that's how I would do that up here as well. This is why my code might look like it's positioned slightly different to yours, but actually it will still read the same way to the computer. It's just my human eye is designed to do the way I've been taught to do things. So I'm just going to finish that off like that. Okay, so we then remove object 1 and object 2. So what if you have noticed here, what we haven't got as a scenario is the laser and the ship hitting one another. So we obviously can only test for what we need to. That's removing those. But then obviously I've lost my screen. If we're going to deal with the asteroids that are in the asteroids table, and we don't want to bleed memory by creating data for objects that no longer exist. So inside our then statement, we're here, we are going to create, so we've got to grab the object from the asteroids table, and we've got to identify if that happens to be object 1 or if it's object 2. If it is, then we're going to remove it from the asteroids table, break out of our if statement, because otherwise we're in a loop and it can go, because it's got to check. So basically what's happening here is we've got an if statement inside a for loop. So whilst we are checking every asteroid that lives inside that table until we identify the one at that position, and it's either going to be in position object location 1 or position object location 2, that's fine. Once it's found, we're going to remove it from the table, and then we're going to break out of our for loop. Okay. There we go. Now once we've done that, obviously this is between the laser and an asteroid. We've had a successful hit. We're going to update our score. Whilst we're still dealing with this begin event, we are going to get the score, We're going to add 100 points to the score. So whatever the score is, it's currently 0. Right at the very top screen, we set the score to 0. So the very first time one of our lasers hits an asteroid, we're going to score 100 points and we're going to overwrite that value. And then obviously, just like we did with the balloon, we're going to have to write that detail to screen. So this is a concatenation statement here. So this is text, and then we're going to add to that text the value of the score, and then we're going to overwrite the text of our score text. Okay, so that happens to be that. So let's just save and see what happens, see if it actually updates or if we've got any challenges. So there are our asteroids. Notice that they're all coming in from different directions. Okay, they're all moving at different speeds and they are all spinning in different directions. That one's kind of on the spot spinning, and this one's going quite fast. This one's turning to the right, etc. Now if I fire my ship, nothing is actually updating, so we'll have to check that in a minute, but we can move it left and right, and obviously I've got to figure this out because it's not quite moving. But if you did notice there, our asteroids know that they exist because they're banging into one another and going off in another direction, but they're all the exact same image at the moment, which we need to do something about as well, I should imagine, at some point in the game as well. So where are we now? Asteroids and the ship. So else, now this is where we've got to check for the other scenario. So this is all inside our if statement here. So else if there we go. I'm just going to move this around. There we go. Then if it's not the laser and an asteroid, we look at the other pair, which is the ship being hit into an asteroid, or is the asteroid hitting into a ship? And again, we've got to deal with it. So pretty much in the same way as well. So we have got this time, if the ship hits something, or the something hits the ship, then it's going to die. Okay, so that's our died status from before. Up here somewhere, died equals false. Okay, all right. So we're going to now if died equals false, then we are going to put died as true. Dun, dun, dun. So it's always false unless we've hit something, which is why it then suddenly becomes true. Okay, we're going to hit end, that's fine. And now we are going to update our lives here. So let's update our lives. And that is taking place here. And I think I've just realised I've put that in the wrong place, which is why it wasn't working. So let's have a look. Where is the score? This is why we need to line our code up in the correct location, because I've put it in the wrong place because of the way that they have got this moving. So if we are in here and there and we've done that, then we need to do that. And that's just an example of why and how we need to make sure we've indented our code correctly so that we can work out what exactly is going on and why the code belongs to what text. Okay, so we need to deal with the ship and how it works on screen. So my code, right, so we are underneath where we report the lives, which we will look into in just a second. We are going to put the lives in here. So if the lives are 0, then display remove the ship from the screen, because obviously we've got nothing to live with. Else ship alpha is 0, and we're going to wait 1,000 seconds before we call the function to restore the ship, and the restore the ship was the one that we've just done. Okay, and then we will store it back to, and obviously that's fine. And now we just need to listen to our runtime collision. Okay, there we go. We are on collision, and there, runtime. It's outside of the code because obviously it can't call it itself. So let's just tidy up my code. Right, save. So our ship, oh look, see, now we can kill our, we can move it right. I can kill, our score's gone up to 800. We're still on 3 lives. I'm going to die. Let me hit a clock. Oh no, it's disappeared. So I'm down to 1 life. Oh, I don't know how that quite, maybe the maths wasn't there quite, or I'd already hit 1. Let's hit and let's see what happens when we die. It's going to hit us. Now we're at -1 lives. Okay, so it's doing its job. It's coming back in and fading in after 4 seconds. We are hitting objects nicely and we're at now -3 lives. So obviously we've got to catch this, but we can start firing and moving. So we've got a game of sorts taking place now, which is kind of cool. We can't go up and over our asteroid, so I'm going to get pinned in the corner here. Oh, there we go. Anyway, so we can see that this is kind of happening the way. There's some refinements to do, but it's getting in the right direction. Okay, so collision listener, we've done that, and there we go. There are our concepts. Okay, so that's pretty much brought us to the end of our chapter. Obviously there are some little concerns there that we need to fix, so I am going to go and have a look and see if they are fixed on the next chapter, or if there is something in the code that we need to tweak that they didn't cover, or if I've missed something. But essentially we have now brought our game this chapter to a close. So as before, at the bottom of that screen there, all the different concepts that we have worked with are all identified down here, that you can go and have a look and read up on those a little bit more. And I will start the next video with any of the solutions needed for explaining why our maths wasn't quite working on the scores. Okay, so if you really enjoyed that, thank you very much. Don't forget, click the subscribe button, hit the bell, and I'll see you on chapter 4. Thank you.